Hey everybody, welcome back to another 2-Min Maths video. Today we're going to be talking about exponential functions and modeling them using the special term e, which I don't think I've really talked a lot about in my channel, so I'm really excited to be diving into this. So the model for exponential growth is y equals a times e to the power of bx, where b is considered greater than 0. And here's an example of an exponential growth model. And decay is very similar, except that there's a negative in the exponent. So as you can see, it decays. The magnitude of the y value decreases. And here's an example of that sort of model. Now, some ways to kind of understand that it's going to be an exponential growth model is if it's talking about an increase in population or interest. And some terms that's usually associated with exponential decay models is half-life or depreciation, something that's losing value exponentially. And a good tip is remember to not round as you go. Now let's look at an example. The population p of a place is this following exponential growth function. Why is that? Because the exponent is positive. Where t equals 0 at that specific date, how many years does it take for the population to reach 150k people? Now luckily for us, they gave us the exponential growth function, but usually at these types of problems, you want to kind of ask yourself, is this, an exponential growth or decay problem? And as we know, it's exponential growth. So we have to basically set this following exponential growth function equal to 150,000, and ultimately we have to solve for t. So let's divide both sides by 95,000 to kind of isolate t, and now we're going to take the natural log of both sides. And after that, we have one of our favorite properties, which is we know that natural log of e equals 1, so we can kind of cancel that out. And we have the following, and all we have to do is isolate t and plug this bad boy into our calculator, and we get that t is approximately 8.3 years, which is approximately 9 years, because note that it doesn't reach 150k residents at 8 years, so the year after that, if it's asking for integer value, would be 9 years. Now you can take a step further and ask yourself what year and month will it equal 150k? And the correct answer for that would be the April of 2004. Remember, for this, you would actually take 8 years and not 3, but 4 months, because technically it doesn't reach at 3 months, which would be March. It reaches the month after, which is April. I hope this video helped. Comment down below any of my topics from interview. Thank you.